Okay, let's begin Unit 3A, Day 1. This unit is all about triangles and congruency. So in Day 1, we're going to just do a little introduction to triangles. Most of this you have heard before. Some of it will be new. So a triangle that has 3 acute angles, acute meaning less than 90 degrees. Okay, 3 acute angles would be an acute triangle. If it has one obtuse angle, obtuse meaning it's greater than 90 degrees, then the entire triangle would be classified as obtuse. An obtuse triangle. If it has one right angle, so right angle, 90 degrees, the entire triangle is classified as a right triangle. More specifically, all 3 of these angles are congruent, so 3 congruent angles. All of them would be less than 90. They are acute, so this is an acute triangle, but more specifically, it is an equiangular triangle. A triangle where all the angles are equal. Now let's classify them by their sides. If we have 3 congruent sides, we know they're congruent because of these markings here. Then this is called an equilateral triangle. If we have a triangle that has 2 of the sides congruent, we call this an isosceles triangle. If we have a triangle that no sides are congruent, none of these sides are the same length, we call this scalene triangle. In this first section, let's classify by both the angles and the sides. So I typically start with angles first. So here, we have each of these angles is 60 degrees. Okay, so they're all less than 90, so it's acute, but more specifically, all of the angles are the same. So this is equiangular. And now the sides, all of the sides are the exact same length, so equilateral. Number 2. Okay, we have 2 of the sides the same length. The third is not the same length. So this is isosceles. And the angles here, we have a 39, and a 102. So 2 acute, but 1 obtuse. If there's 1 obtuse, then the entire triangle would be classified as obtuse. So this is an obtuse scalene triangle. 3. Angles here, we have 2 acute angles and 1 right angle. Because of that right angle, it is a right triangle. And let's look at the sides. We've got 11.1, 10.1, and 4.7. None of those are the same length, so we call this one scalene. A right scalene triangle. Number 4. The angles, every single one of these angles is less than 90. And these 2 angles are the same length, measurement. So this would be acute. And now by the sides, these sides are the same length, and we have a separate one here. If 2 of the sides are the same length, we call that isosceles. Notice in this isosceles triangle, the 2 angles that aren't between the congruent sides are the same length. Let's see if that's true for this isosceles triangle. So the 2 angles that are not between those sides are the same. Flip to the next page. It says triangle ABC has the following vertex coordinates. Use the distance formula to find the side measurements and classify the triangle by its sides. Justify by showing your work. So I've given you the distance formula there, and we need to classify by its sides. So what we're going to do is we're going to find the length of AB, we're going to find the length of BC and AC. If any of these come out to be the same, then we can classify. So we're looking to classify as equilateral, isosceles, or scalene. So let's go ahead and start with AB. So remember, this is x and y, x and y. So the square root of, so I'm going to go 2 to the 3. So 2 minus negative 3, so plus 3, squared, plus 0 minus 2, squared. 2 plus 3 is 5. 5 squared is 25. Plus 0 minus 2 is negative 2. Negative 2 squared is 4. So this is the square root of 29. I don't really need to go any further because I can still compare their square roots. If I wanted to, I could round that to the nearest tenth. Not really necessary. Now BC. So I'm going to go 0 minus 2 squared plus 4 minus 0 squared. 0 minus 2 is negative 2. Squaring that, I will get 4. 4 minus 0 is 4. 4 squared is 16. So this is square root of 20. So right now, I know that this is not equilateral because these are not congruent. Let's find the third side. AC, so 0 minus negative 3, so 0 plus 3 squared plus 4 minus 2 squared. 0 plus 3 is 3. Squared is 9 plus 4 minus 2 is 2. 2 squared is 4. 9 plus 4 is 13. Okay, all of these are different. None of them are the same measurement. So all sides are different lengths. This is a scalene. Try number 6 on your own. So let's do AB first. AB, we have 2 plus 1 squared plus 4 minus 3 squared. Try this one on your own, pause it and come back. Okay. Here's my work. If you did not get isosceles, go ahead and finish watching number 6 with us. If you did get this, you can go ahead and skip to the next question on the video. I'll go ahead and finish 6 for those of you that did not get it. So we have 2 plus 1 is 3. 3 squared is 9. 4 minus 3 is 1. 1 squared is 1. And so I have square root of 10. Then I have BC, square root of 1 minus 2 squared plus 1 minus 4 squared. 1 minus 2 is 1. 1 squared is still 1 plus 1 minus 4 is 3. 3 squared is 9. Square root of 10. Now for AC. I've got the square root of 1 plus 1 squared plus 1 minus 3 squared. 1 plus 1 is 2. 2 squared is 4 plus 1 minus 3 is negative 2. Negative 2 squared is still 4. So I have the square root of 8. So right now I have 2 of these sides being congruent. This makes this an isosceles triangle. Next part here is triangle segments. So we can cut our triangles in 4 different ways and find different measurements. The first being a perpendicular bisector. So what does that mean? Write down here, please. Bisects one side at 90 degrees. So bisects means it cuts it right in half. Okay, I'm going to go up to the other leg up here, and it's 90 degrees. Perpendicular bisector. The next one is an altitude. So an altitude is kind of like height. If we don't have a height indicator or a right triangle. So this is the vertex that's perpendicular to the opposite side. So I'm going to take this vertex here and bring it straight down to the opposite side, and it'll be perpendicular. So 90 degrees. If I had a triangle that was obtuse, but maybe it was sitting like this, my altitude could lie outside the triangle. So this vertex right here, bringing that straight down at 90 degrees, I could have the altitude landing right out here like that. Median. Median meaning middle. So a median is the vertex to the opposite side, cutting the side at the middle. So the vertex to the opposite side, cutting side at midpoint. So vertex bisecting the other side. So I'm going to bisect this side, meaning I'm going to cut it right in half. So I'm going to use these notations saying these are the same lengths. I'm going to go from the vertex on the opposite side there, straight down. Let's say I had a triangle that was scalene, so I'm going to draw something like this. I'm going to take this vertex here to this side. So I'm going to cut this side in half. I'm just eyeballing it. So that looks like about half. So I'm going to go from this opposite vertex to that angle. That would be a median. Last piece is angle bisector. For our angle bisector, it kind of says it in the name. It's going to bisect the angle going to the opposite side. So vertex to opposite side, cutting the angle in half. So we're not worried about where it's cutting this side. We are, however, worried about cutting this angle itself directly in half. And then we just bring it down to the opposite side. 9, 10, 11, and 12 are you trying it on your own. So my recommendation with this video is try it on your own and then check it with my video. So an angle bisector, I could cut any of these angles. If you cut this angle up here, we'd be doing exactly what we did here. I'm going to go from this angle here just to give you a different viewpoint. So if I cut this angle in half, it looks something like this. I do need to put notation markers on here that was right down the middle, meaning these two angles are congruent. Perpendicular bisector, it's bisecting one of the sides at 90 degrees. So it's going to bisect this side. So these two pieces are congruent, and I need a 90-degree mark, so I'm just going to go straight up from here. So we have 90 degrees. There's multiple ways this one could look. Altitude. So our altitude for this one is the vertex to the opposite side. So I could bring our altitude outside my triangle like so. Okay, and bring it just like that. I could also turn this paper if I wanted to, and have my triangle facing about this way, and have it like so. So there's multiple ways I could do this. Let's do median, last one here. Median is cutting one of the sides in half. So if I wanted to cut this top side in half, I'd look about right here, so marking that that was congruent segments going from the opposite angle to it. Could do the same thing with, let's go with this vertex. So I'm cutting this side in half. I'll put 2 marks each, going from this angle to that point.